Incredible? Dam construction engineering is beyond mind-blowing. Damming has been an important engineering practice for thousands of years, with the first dam being constructed by ancient Egyptians around 2800 BC. Dams are built to block the flow of water, creating a reservoir behind the dam that can be used for flood control, as well as irrigation, municipal water supply, and other human activities. Inspired by a recent news story of dam failure in California, this blog looks at how dams have historically been constructed in the last 100 years, and what improvements are necessary in dam construction moving forward. How to build a dam? Building a dam is a complex multi-step process that requires huge amounts of manpower, raw materials, and investment. Here are the basic steps to building a gravity dam, the most common type of dam that we build. Gravity dams are so named because they are held to the ground by gravity. They weigh a lot and are typically made from concrete or stone. 1. Engineers must water the river where the dam is meant to be built. This is done by diverting the river through a tunnel that runs around the intended construction zone. Tunnels like this may be lined with concrete and are usually dug out using a combination of drilling and explosives. 2. Dam construction must be started when river levels are low. A small dam called a cofferdam is built upstream of the construction zone to help funnel water into the diversion tunnel. A cofferdam may be built downstream as well, but the overall goal is to keep the construction zone dry so that the main dam can be built. Pumps may be used to remove water that penetrates the cofferdam. 3. Loose rock is removed from the riverbed, and a plinth must be constructed. A plinth is a concrete foundation for the dam that embeds it in the walls and floor of the riverbed valley. This prevents water from leaking at the edges of the dam. 4. Now, it's time to build the dam to its desired height. A concave curved downstream surface for a dam helps it absorb the constant pressure of water that it must endure. Reinforced steel is used for the surfaces of the dam itself, and an enclosure is built. The enclosure is filled with concrete to make it extremely strong and resilient against water flow. Mainly the following structures are constructed connected with the dam's spillway. It is the key structure connected to the dam body. Whether the dam is concrete, rock fill, earth, etc. A spillway is constructed to control the additional water collected in the reservoir and to maintain the reservoir at the optimum operating level. The elements such as OG, weir, gates, control systems, gatehouses, chute, and stilling basin are the key structures included in the spillway. In addition, there could be bridges, mostly post-tensioned, over the spillways. Guide walls. Usually there are guide walls beside the spillways. One could work as the abutment to the embankment as indicated in the above figure. The other one, on the right, constructs to act as the abutment to the dam. Guide walls are fairly large structures, as mostly in the hydraulic structures. Most of the hydraulic structures fall in between the gravity and the retaining wall structures. They are provided reinforcement to carry the forces. In addition, due to the limitation of the deflection also, fairly higher thicknesses are used in the design and construction. For example, when the dam body is connected with the guide wall, if it moves due to the lateral load, the dam could fail due to the movement in the dam body in the direction of the wall. The lateral deflection will be higher for these structures if they do not have adequate lateral stiffness, as the retaining heights are very high. Further, it is required to limit the deflection of the spillway sidewalls to operate the gate structures properly. The excessive lateral movement could cause the mechanical system to fail. Diversion tunnel and plugs. Construction of diversion tunnels or structures and concrete plugs are quite common in any type of dam. Dams are constructed across the rivers or water paths to stagnate the water. In the construction period of the dam, existing water needs to be diverted in a different direction, or it should be sent downstream without obstructing the construction. When there is a solid rock in the area where the dam is constructed, a tunnel is constructed under the dam body or in a closet area to divert the water. Diversion tunnel should be designed and constructed considering the maximum discharge that could occur in the river. The hydrological studies, done especially on this, shall be the base for selecting the size of the tunnel. In the design of the dam and the spillway, these data are considered. Hence, these data will be available, and the same can be used to design the diversion tunnel. After the construction of the dam, it is required to close the diversion of the water. The mechanism that uses them to stop the water movement or seal the tunnel is called a concrete plug. A concrete plug is a mass concrete or reinforced concrete fill that is constructed to seal the tunnel. After concreting the plug, injection of the grout is done to make sure there are no cavities in the concrete, especially at the top of the plug. Bottom outlets. The name itself provides an idea about the structure. Bottom outlets are constructed in reservoirs at the lowest level of the structure. It consists of a gate structure that enables the release of the water. Release ecological discharges, which require to maintain the stability of the environment, and for cater the requirements of the downstream uses. Use supply water for downstream irrigation systems existed before the construction of the dam. Release the extra water from the reservoir. Used to lower the water level of the reservoir, for maintenance work, etc. Are some of the most important uses: transfer channel and tunnel. The transfer channel is constructed to divert the water in a reservoir to some area or to another reservoir. When there is a small dam that is able to collect water, transfer channels are used to send water to the main reservoir. A transfer channel could be an open channel or tunnel. At the starting form of the reservoir, it is mostly a tunnel. However, beyond a certain distance, it could be constructed as an open channel based on the topography of the area. Further, the construction of a tunnel is a costly option. The irrigation water supply. One of the most important purposes of a dam is to use the collected water in the reservoir for irrigation. Irrigation outputs are constructed as tunnel structures at the beginning of the water supply. Same as the transfer channels, these structures are also constructed in a similar manner. Intake for power generation and power station. Most of the major dams are constructed for generating hydropower. It is one of the energy sources that does not do any harm to nature. Intake structures are constructed connected to the dam or in some other place in the reservoir that has the adequate head or at the location where it creates the maximum head. Water head is one of the most important energies that is converted to electricity. Based on the design, especially when the high head is used for power generation, power stations are constructed far away from the intake. When the discharge is based, turbines are used. Where it is not possible to have a higher head, power intake and power station are very close to the dam. Power station could be constructed as part of the dam structure when the dam is a concrete structure, or it could be constructed jointly. Grout curtain. It is the main obstruction to the movement of the water under the dam body. Even though most types of dam are constructed in rock foundations, there could be seepage paths, cavities, etc., where it enables the movement of the water. Rock is not impermeable. It has to be grouted to fill the cavities, cracks, weathered zones, etc. Extend and the number of grout holes, or the pattern of the grout holes, shall be as per the condition of the rock. In some of the dams, an inspection gallery or the grouting gallery is constructed to do the necessary grouting even after the construction is based on the seepages downstream. In addition, the construction of a grout curtain reduces upthrust or the uplift pressure on the dam. It reduces the dam stability issues significantly. Saddle dam. If briefly outlined about saddle dams, it is one of the types of dam which could not be that big as the main dam that was constructed to avoid the movement of the water when the reservoir gets filled. The dam creates a reservoir where it spreads over a larger area. The following figure taken from the internet indicates a saddle dam. There could be places that need blocking the movement of the water when the water level rises. Those small dams are called the saddle dams. However, in some situations, a saddle dam may also be a large dam as the reservoir gets larger. Hope it was informative. Subscribe for more.